With this introduction, may I invite Mr. Chandrashekar Bharathi, who is MD of AceMicromatic. He is an MS from State University of New York with BE and PGDM from ISC Bangalore, and an entrepreneur and technology visionary. He serves as director of the board and at the IMTMA, Indian Machine Tools Manufacturers Association, and member of CA's National Manufacturing Committee. Currently is MD of AceMicromatic.
I'm here to talk about how AI is used in manufacturing industries and what is the contribution that our group, AceMicromatic group, has been able to do for this in terms of the discrete manufacturing industry to start with. This one, right? Okay. Okay, there we go. So, whatever I'm going to talk about is in the context of who we are. We manufacture CNC machines, and this year we are going to manufacture 10,000 CNC machines. So, anything that we do, thank you. So, anything that we do actually has to pass 3 gates. One is, it should actually work from day one, because you really cannot experiment with production machines in the field. In the same way, what we do with AI is part of the same stage gating process as well. It should work from day one. Second, it should provide value and ROI from day one, and an ROI that is literally measured in either weeks or months, not years. That's the second aspect. The third is, it should be something that is structurally flexible to grow with the needs of the customer. So these are the 3 stage gates that we use when we do AI. And what I'm going to talk about today is how we approach AI. See, there's a lot of talk about Copilot and ChatGPT, and there's a lot of experimentation that happens with that. But when we look at industrial AI, there are so many aspects to what an industry does in the course of its day-to-day working. And our AI looks at it as a sum of the parts. It isn't just one thing that you do here, one thing that you do here, but we really try to connect all of this together. And here, I take inspiration from what Professor Motwani said in the previous session, what Dr. Joshi said, which is how to make this real, right? And that's the perspective that we have taken. And what we have done is, we've built a platform, much in the same way like how there is UPI that's transformed the financial industry. I mean, I don't believe that manufacturing has the luxury of having a unified interface like that completely, but that's where we are trying to go with this, which is like the UPI for manufacturing. So we have the ability to ingest data from a variety of sources. It could be production machines, sensors, metrology equipment, human factors, anything, right? And we've also put in new paradigms. What you say there is MIoT on CNC. It's actually a thin layer of software, IoT software that goes onto the CNC machines themselves. It's actually pretty revolutionary, because what it does is it takes away one of the last friction points of how do you engage with the operator to become part of the whole Industry 4, Industry 5 paradigm. Again, the previous speaker, Ms. Esther, talked about skilling the workforce. One is, of course, skilling the workforce. The second is making technology so easy to use that they, in some cases, don't even have to be skilled for that. So that's the other aspect. The second aspect of that is, how do you look at real-time aspects of what you do with data? For example, what do you interlock? What do you make sure that there is a digital thread that runs through the whole process, which, if it is compromised, things that need to happen to the process. So that is part of what we call a hot path. The warm path is near real time. What needs to happen either by exception or by hour, or when a particular event is triggered, that type of thing, okay? What we have done with this is, with this infrastructure is, not only have we woven a digital thread across all the different operations of what happens in a typical manufacturing industry, we've enabled the ability to add virtually any kind of application. We're all familiar with, the Android operating system or the Apple or whatever, right? Where there are so many apps, and those apps would not have been there yesterday. In the same way, manufacturing industries need use cases that will keep transforming and growing. That's the same perspective that we have brought to the application ecosystem. And through all this, there is an industrial AI tech stack. I'm not going to talk much about the technology behind it because that's going to take significant depth to go into. But what I'm going to show is some of the end users, some of the outcomes that have actually come out of that. And that's where we make it real for manufacturers every single day. Now here, we have AI for quality, what we call physical AI, right? In fact, the NVIDIA founder talks about physical AI being the next big thing compared to anything else. So that's physical AI. AI for safety. We don't really address that upfront, but safety is a very important part of quality and reliability, right? So, maintenance, vision-based AI, production AI, and several other things. So I'm going to share a few use cases of this. The first use case that I'm going to share is obviously the physical AI, because there's a lot of buzz about that. And here, what we mean by physical AI is the ability to harmonize every second of activity between production machines, production lines, metrology, robots, cobots, AGVs, AMRs. In this particular use case, what we have done is we have taken almost 75 high-frequency parameters from the running CNC machines, using that into a forecast model to say when is the next activity that needs to happen that's physical in nature. For example, where is the next load-unload happening? Where is maybe an inspection that is required to happen? Things of that nature, right? The end goal is to make this a lights-out operation. We hear about China's dark factories. Now, India's dark factories are coming, and it is going to start accelerating as more and more people understand that this is something that is real and can be done without significant changes to what is happening. Okay? Let me play this video for you, and you'll see parts of what is happening is, one is there are CNC machines, there is robots, there is AGVs, all of them are being harmonized to perform basically a lights-out operation. So let me just stop that there. And what just happened there is, in that cell, there were 8 people who actually got moved up the value chain. They're not doing the jobs that they used to do. They've gotten higher order jobs to do, which is also benefiting the company apart from making this a lights-out factory. Okay? The second is, we talked about it has to work from day one. So we've actually done a whole bunch of applications which are like utilities on tap. You turn on the tap, you get something, you fill your glass and you shut it off, right? So like that, we built a whole series of things. See, at AceMicromatic Group, we have more than 100,000 machines in the field, working CNC machines. And we have deep data about these machines, whether it is service history, there's alarms, there's operational data, and so many things. So using all of this, we have built a very, very fine-tuned model which can address, you'll see what it addresses, but it can address a lot of things. Now, on top of that, we can do something called a RAG of customer data. So what it does is, using customer data, it finds answers, and where that data isn't enough, it goes back to the model, brings back the answers, requalifies it with customer data, right? This is one. There's a whole bunch of things on vision. Again, one favorite topic for a lot of manufacturers, we look at drawings, we look at parameters, what to extract, CTQs, and so on, right? Now, how many of you think that is a fun task to do? Looking at drawings, manually doing things. I don't see too many hands, right? So we actually solve that problem. Okay? Scheduling, again, it is considered to be part of what we do, but it's one of the toughest things to do. So we built something called an auto scheduler using a genetic AI algorithm. That algorithm is like an embryo, which knows how to divide its own cells, how something becomes this organ, how something. In the same way, this scheduler learns from itself every time. Okay? Agentic AI, and many, many other things. So let me walk you through some of these things. So this is the Mitra, which takes in manuals, takes in alarm history, service history, operations history, and does this.
Meet AMG Mitra, your intelligent co-pilot on the shop floor. Imagine this, a manufacturing plant where machines don't just operate, they think, analyze, and respond. That's the promise of AMG Mitra, an agentic AI assistant embedded right into smart manufacturing environments. Let's take a closer look at how it works in action. Here, it's asked about machines that pose a high risk of failure. To answer, Mitra queries past records for machines in the current plant, runs a trend analysis module, derives insights, compares those insights with current runtime data, and then gives a clear list of machines that meet the criteria. When asked about top-performing machines, Mitra calculates AE, PE, and QE in real time and uses these to derive the OEE for every machine on the floor. It doesn't stop at numbers. Mitra summarizes the answer with key highlights, gives a clear verdict, and visualizes the final outcomes, making complex data easy to act on. As mentioned earlier, Mitra can resolve alarms too. It identifies alarms based on their number or message, pinpoints the reason from manuals, and outlines the exact steps needed for resolution. Mitra learns from those massive operator manuals and acts like a personal assistant, pulling out the daily maintenance checklist on demand. It can even handle technical queries like, what's the function of G95? With access to complete past service records, Mitra can suggest fixes by referencing past solutions, like a dictionary of resolved machine issues. And the best part? Mitra is mobile-ready. It communicates directly through your phone, delivering insights like the overall carbon footprint of your plant right into your pocket.
Let's look at how we actually extend that.
Welcome to our Plus AI Tools, your partner in empowering smart factories. Let's explore how our innovative solutions can streamline your manufacturing processes, covering maintenance and production. Let's begin with downtime analytics. By harnessing real-time data on cycle time, power-on status, and program selection, you can uncover hidden bottlenecks and eliminate costly production delays. Our system provides a comprehensive overview of your downtime, highlighting the total hours, number of events, machines affected, and the primary reasons for downtime. This allows you to quickly identify the top contributing factors to downtime, such as the top 3 machines shown here. Delving deeper, we can analyze downtime for specific machines and aggregate this data. This is achieved using automated data collection systems directly from your CNC machines. Our AI employs robust anomaly detection models to pinpoint unusual patterns. The downtime is then classified into different categories based on duration, from short disruptions to longer outages. This classification provides a clear breakdown of downtime occurrences. Furthermore, a consolidated trend summary offers insights into the status of each downtime category, indicating whether it's stable, worsening, or improving, allowing for targeted interventions. Finally, we introduce downtime probability. This feature leverages AI to forecast potential downtime events. It assesses the current risk level for different downtime durations, providing probabilities of occurrence within specific timeframes, and highlighting recent occurrences. This proactive approach allows you to anticipate and mitigate potential issues before they impact your production. Based on this analysis, Mitra, our intelligent manufacturing assistant, highlights likely reasons for the downtime, such as vibration, system failure, coolant, and provides actionable suggestions to improve your factory's performance. These recommendations include checking spindle bearing, regular lubrication schedules, and proper replacement of components. All this contribute to an informed decision-making, resulting in higher uptimes for your machines.
So this is, we all deal with ballooning. So let's look at how that can be simply automated. There isn't a voiceover here, but it's pretty easy to follow through. And again, this is not just image recognition, there's a lot of AI in it which hooks into an application engineering database. So you see that the confidence level is pretty high, right? And then it ends up with a list of CTQs that gets plugged into a quality system. So because of time, let me go to the next one. Again, the scheduling part of it. This is the genetic AI algorithm that I talked about.
This is an automated scheduling application designed to optimize workflows on shop floors by scheduling tasks and allocating resources. It helps improve productivity and efficiency by providing a visual and data-driven overview of job execution, machine utilization, and operator performance. The application's main function is to generate and download a schedule. This process involves a series of steps. You begin by uploading a master schedule file in a compatible format, like an Excel spreadsheet. Next, you upload a daily dynamics file, which likely contains updated information for the day's tasks. You then set a start date and time for the new schedule. The application offers different scheduling algorithms to choose from. You also select an allocation algorithm to determine how tasks are assigned to machines. After selecting the algorithms, the application processes the data and generates a new schedule. The final schedule can be downloaded as an Excel file. The application provides a variety of graphs and charts for a comprehensive analysis of the generated schedule, the job count per machine, machine utilization, downtime and idle time, machine-wise job execution, job timeline with due dates, and sorted results.
So again, we talked about vision AI, whether it's part detection and counting, presence detection, orientation, size detection, and corrections to the process. Let me show a few of these examples. So accurate counting on conveyor lines, even if there are multiple part families, it's a problem that solves a huge gap for a lot of manufacturers. Right? The ability to look up process data, the ability to look up traceability based on part being detected. Depending on the wheel size, this is actually adjusting the parameters to the machining process. Then the ability to detect surfaces, anomalies on the surfaces, things of that nature. Right? Again, quality through safety. We talked about safety being a critical vector. So this is an example where
on today's shop floors, human safety is non-negotiable, especially around CNC machines, robotic arms, and feeder belts. Traditionally, curtain walls have been used to keep operators safe, but they are rigid, costly, and limit flexibility. With our vision-based virtual boundary system, this is reimagined. Using camera-driven monitoring, it creates an invisible yet reliable boundary around critical zones. The moment an operator steps into this restricted area, the system instantly detects the intrusion, triggers alarms, and can even stop the machine to prevent accidents.
The last thing I'd like to talk about is, sorry, can we go back? Can you go back, please? Go back one slide. I mean, this is something that is going to come up maybe in the next 12 to 18 months. But we're actually working with psychologists, behavioral scientists, to even look at if an operator is fatigued and how do we actually alert both the operator and perhaps the ecosystem to ensure that fatigue doesn't cause a safety issue or a quality issue or worse, accidents. Okay? So these are some examples of how AI is being deployed and deployed at scale, like UPI for manufacturing. Thank you very much.
So at the end of the session, what is the impression all of you have got? நாளையிலேருந்து ஏஐன்னு ஒன்று வந்து ஏதோ பண்ண போகுது, குவாலிட்டி நம்ம எந்த வேலையும் பண்ண வேண்டாம், அதானே? Future தான், future it has already come. We are seeing AI every day now. See, please, I just try to quote my mentor and professional guide, Dr. Ravichandran. Nothing in manufacturing will work if you don't touch the process, touch the machine, touch the people. AI can only help you, augment you. Definitely you need AI, but it has to augment all of our process and make it an excellent one to improve our efficiency and productivity. And finally, I would like to quote from today morning. I have been hearing right from our chief guest, Mr. T.K. Balaji, about China, and followed by our ex-chairman of ISRO. I would like to share my experience of China. In 2019, month of September, I visited a place called Wuhan. That time I didn't know about Wuhan. If I had known, I would not have gone. I went there to source a machine for laser cladding. You know, we are making engine walls. At the tip of the wall, we need to deposit a stellite material. Just 0.2 mm, we need to make a dish and then deposit this. I happened to go there, and we had connected with a supplier in Wuhan. And the promoter was a lady. She took me in her car. It was like a big township. I am from Neyveli, so I am saying that it is like a Neyveli township. Huge place, only for laser. There are about hundreds of offices, factories, etc. Everybody is specializing on laser. So she took me to her office, and then I explained what is that I need. She noted down. She couldn't understand and comprehend. So she told me, come on with me. She took again in her car into the same township in a central place. There is a very big university. Again, that university in that Wuhan township is focusing only on laser research. So she put me in front of a professor. I did the same, explained the same thing. He took me around the university. He showed me laser cladding from small thing to a very big shaft, turbine shafts, and how the machine is being designed. He gave that design to this supplier, and then she made that design, and then they supplied. Now, why I'm saying this is, like we listened in the morning, China is growing, China is prospering because they also invest in this type of thing. We talk about isolation like IIT Madras and some of the institutes, but I think every township should be developed for each one of these different fields, and we should also, the institutes also should support, and particularly like our country where we have MSMEs, if that type of support is extended, I think definitely India can prosper better than anybody else. With this, I conclude this session, and thank you.
Thank you, sir, for gracing this occasion.